So now that we know how to work with implicit differentiation and we have an idea of how the process works, how to use a defined slope, I want to spend this lesson kind of focusing on what else can you do. Kind of taking what we did in the previous lesson and extending it a little bit further. So there are a couple different types of questions on Delta Math that I really like that kind of show this extension. So here's one of them. This is one where they give you an equation that's in an implicit form, and then they ask for the tangent line equations, specifically when, in this case, y equals 3. And one thing I want you to notice is it says tangent lines. This is plural, and this is purposely plural. Anytime the AP test writers ask you to write an equation of lines instead of line, they're telling you without coming out and like screaming it at you that there's going to be more than one line answer. So let's start by taking the derivative. So we're going to do a product rule. So first times the derivative of the second, derivative of y squared is 2y dy dx, plus the second times the derivative of the first, which is just going to be y squared times 1, plus the derivative of 3x squared is 6x, minus 3, the derivative of that is 0, plus the derivative of y squared is 2y dy dx, equals 0. And I'm going to move these two. So I have a negative y squared and a negative 6x. And if you want to kind of clean up here, I'm going to pull a dy dx out on this side. And I've got 2xy plus 2y. Then I'm going to divide. And there's my derivative. So the problem wants to know what are the equations of the tangent lines when y equals 3. Well, here's the big issue here. I know what y is, I don't know what x is. So I always go back to the original function anytime I have one variable value and I want the other one. So when I put 3 in, I'm going to do my work off to the upper right here. So when I put 3 in, I'm going to get x times 3 squared is 9 plus 3x squared minus 3 plus 3 squared equals 0. And I'm going to kind of just get this in a better form. So I have 3x squared plus 9x plus 6. Now, if they let you use a calculator, you could potentially have some really messy answers for x. This one, a lot of these on Delta Math, they do without calculator, which I actually prefer. You can factor a 3 out, so you get x squared plus 3x plus 2. And then you can go a step further and get x plus 1, x plus 2, which means my x values are -1 and -2. So here's why the question wanted the equations of the lines instead of line. You actually have 2 points you're working with. You're working with the point -1, 3, and then you're also working with the point -2, 3, because there are 2 x values that give you a y value of 3. So now to find slope for each of them, I'm basically treating them as 2 separate problems. When I put -1, 3 into this derivative equation, I'm going to get -9. So I did -3 squared minus 6 times 3 is minus 18 over 2 times -1 times 3. So 2 times -1 is -2 times 3 is -6 plus 2 times 3 is 6. So I get -27 over 0. What that means is I have an undefined slope, so I must have a vertical tangent line because I have a slope that is undefined. So here's what you should know from Algebra 1. If you want to write an equation of a vertical line, it is just x equals whatever the x value is. So my tangent line is actually a vertical tangent line, and it will just be x equals -1 because the slope is undefined. Next one, -2, 3. When I put -2, 3 into my derivative equation, I get -9 minus 6 times, oh, I had this numerator wrong. I'm sorry. Minus, you're probably watching it going, what is she doing? -6 times -1 is, again, in the end, it doesn't really matter because you still get an undefined slope, but I should at least have that math right. So -9 minus 6 times -2 is plus 12 over 2 times x times y, so 2 times -2 times 3 is -12, plus 2 times 3 is 6. So we get 3 on top, -6 on the bottom, so I get a slope of -1/2. So my tangent line equation would be y minus 3 equals -1/2, x plus 2. Again, I think point slope's the easiest way to write that, but on all you need is your x, your y, which you had over here, and then your slope, which you found using the derivative. So let me show you what this looks like. I actually have this picture from Delta Math. So your kind of sideways parabola, I realize it's not a parabola, is the function, there's the equation that was given. I shouldn't even say function because it's not. And at x equals negative, or at y equals 3, so here's y equals 3, we have two lines that can be drawn that are tangent to the graph. The one is drawn straight up and down, and the one is the one that had the negative 1/2 slope. So you're getting those two answers for your equation. Here's another thing they could ask you to do. They could ask you to take an implicit equation where they're actually telling you the derivative. So this is kind of nice. They save you all those steps of finding the derivative, but they're going to ask you to do something different. They want to know all the coordinates values where y is 1 and the slope is 1/4, or say that there aren't any points like that. So you already know the derivative is 1 plus y over negative x plus 12y squared. And you want that derivative to equal 1/4 because that's what the slope is they're giving you. And further than that, you also want your y value to be 1. So you can replace all your y's with 1. So when you do that, you end up with a numerator that's 2 over negative x plus 12 times 1 squared is just 12 equals 1/4. So now you have to cross multiply. You got to use a little bit of algebra 1 skills, algebra 2 skills. So I'm going to cross multiply. I'm going to subtract 12. And I'm going to divide by a negative 1. So I get x equals 4. And it is possible to get more than one answer because it does say all coordinate points. So I have x equals 1 and x equals 4 and y equals 1. Here's how you check to see if these points actually exist. So you might be looking at it, what do you mean, do they even exist? You should be able to plug these points, these coordinates, the 4 and the 1, back into your original equation, and it should make it true. If it doesn't, what it's basically saying is that point that you thought existed wasn't really a point on the graph. So if I put 4, 1 in, I get negative 4 minus 4 times 1 plus 4 plus 4 times 1 cubed, which is just 1, equals 0. So let's see, I get negative 8 plus 8 equals 0. It checks out. So my coordinate points, in this case, it's coordinate point, is 4, 1. If you go through and do this and you go through the arithmetic and you find your x and y values and you plug it back into the original and you get something that doesn't make sense, like 2 equals 6, something like that, that tells you that those points don't actually exist on the graph of the equation.